Ready. Let's go.
So exam part 3. If f is a vector field, then divergence f is a vector field. This is false, as divergence is a scalar and tells how fields expands, contracts. It's only a magnitude. It's not like a vector field. And then question 2, if f is a vector field, then curl f is a vector field. This is true, as it tells the curl tells how the field rotates, and with rotation, it tells us the direction and magnitude. If f has continuous partial derivatives of all orders on R on the plane
So one and
space
two
R,
are one and two are true.
yeah.
Okay.
All right. Okay. Wait, let me go back. So 2 is true.
Yeah.
1 is false because divergence is only a scalar.
Okay. Yes, you're right.
So question 3. This is true, as the curl of a gradient is always 0, and then divergence of a 0 vector is 0. If f has continuous partial derivatives on the space R and C is any circle, then integral bounded by C, gradient f dot dr equals 0. This is true. Gradient f is conservative vector field. You can parameterize the curve C and then put it into t equals a and t equals b. And then according to the fundamental theorem of line integrals, that integral would equal frb minus fra, and then closed curves means that the start and end points are equal to each other, so that just equals 0. That'd be true. If f and g are vector fields, then and divergence f equals divergence g, then f equals g. This is false. I have a counterexample for this, so we could set f vector equals 0, comma 0, comma 0, and then g vector equals like negative y, comma x, comma 0. If you find the divergence for both f and g, they would both equal 0. But as I said, f does not equal g because 0 does not equal negative y. So yeah, they can differ. Like divergence can equal, but it can differ by curl field, so it'll be false. The work done by a conservative force field in moving a particle around a closed path is 0. This is true, as we find if it's conservative, so then f equals gradient f, and then by the fundamental theorems for line integrals, f basically fn minus f start, and then on a closed curve, start and end points are basically equal to each other, so that equals 0. If S is a sphere and F is a constant vector field, then double integral bounded by S F dot ds equals 0. This is true by the divergence theorem. F is a constant, so gradient dot F equals 0, and then flux is 0. And then evaluate the line integral bounded by C y dx plus x plus y squared dy. C's the eclipse. So then you can set f vector pq, which is equal to y plus, or y comma x plus y squared. find the partial derivatives, or actually find if it's conservative first. So, you know, partial derivative q over partial derivative x equals partial derivative p over partial derivative y. Find those, and then you'll find that they both equal 1. So it means that they are conservative. And then the integral bounded by c f dot dr equals 0 for any closed curve c. Unless it's conservative, so it'd be 0. Evaluate the line integral. For this, I got 110 over 3. So first you can parameterize the integral. R0 equals 1, 1 comma 0 comma negative 1, and then R1 is 3, 4, 2. You parameterize it, it'll be 1 plus 2t comma 4t comma negative 1 plus 3t. And then you can kind of set them equals x, y, z. Find dx, dy, dt, and then sub all that into the integral. So then you'll get x, y, dx equals 8t plus 16t squared dt, y squared, dy equals 64t squared dt, and then yz, dz equals negative 12t plus 36t squared dt. Combine like terms, you'll get negative 4t plus 116t squared. Plug that into the integral and integrate from 0 to 1. That'd give you 101 over 3. For this one, I got the answer as pi over 2. You can use the flux formula and then convert into polar coordinates. Do all that, and then you'll find the answer to the integral is pi over 2. And then the last question. Use Stokes' theorem. For this, I got the answer as negative 4 pi. S is the cap of the sphere based on the question. So then it'll be, the sphere is x squared plus y squared plus z squared equals 5 above the plane z equals 1. Partial derivative S is the boundary formed by the intersection plane z equals 1. So you can, since z equals 1, you can plug it into x squared plus y squared plus z squared equals 5. Now turn it into x squared plus y squared equals 4. So that means the partial derivative of x is just a circle of a radius 2 in the plane z equals 1. Parameterize, you can use x equals 2 cos theta, y equals 2 sine theta, and z equals 1. Bounded by 0 is less than or greater than theta is less than or greater than 2 pi. Do all that. Evaluate f dot dr along the circle. So you'll just get 4 cosine theta sine theta, parentheses 1 minus 4 cosine theta sine theta. Plug that into the integral bounded by 0 to 2 pi. And then once you find the integral of that, you'll find that's negative 4.